Okay. So my name's David Wong, and I just came on as a designated assistant professor this year for the leading program. So I'm based in the Graduate School of Information Science, and today I'm going to be giving you an introduction to Linux. So just before we start, how many of you have used Linux before? No one's used Linux before. Okay, this might be quite a jump in at the deep end, but it's a very, very useful thing to know because, as we'll see later in the lecture, Linux is the basis for many web servers and servers for deep learning and machine learning and these kind of things. Nearly all of them use Linux as a base, so it's a really good tool to know how to use. Okay. So this is an overview of what we're going to go through in today's lecture, starting off with just a brief introduction to what Linux is, and then some tools which are important for being able to use it effectively. So starting off with, what is Linux? Okay, so Linux is an operating system, same as Windows is an operating system. And it's a bit of a funny story that it was started as a backyard project by this Finnish genius, I'd like to say. Actually, this is incorrect. His name is Linus, not Linux. Linus Torvalds of Finland. Okay. Now, he just started this as a project because he wanted to make an operating system which he knew everything about. And this was quite a while ago now, back in '91. So that was back when Windows was probably still DOS, I imagine. This is the tux character for Linux. I don't know if he actually created the tux character or not, but you'll see those products for it. Linux fans tend to use this logo to promote Linux. A little penguin called Tux. So a little bit about how the operating system, how we define an operating system. So we're all used to using software applications, be it on your iPhone or on Windows. Even things like your browser are all top-level software applications, okay? But they operate on top of the operating system. So the operating system is the interface between the hardware of your device and these applications which run on top. And this is true for all devices. So even if it's a smartphone, which has iOS as the operating system, or Windows, which uses computer hardware like what you've got in front of you. So the operating system is the thing you interact with most. So the thing you need to learn how to use, whether it be Linux or Windows, it's the thing you interact with when you deal with a computer. Okay, so in this lecture, we're going to use Linux and get to know how to use the operating system. Now, have you all booted into Linux successfully? What do you have running on your computer currently? Are you in Windows or? You're in Windows? Okay, so now is a good chance for you to reboot your computer, okay? So just go restart or Saikidor, and when the purple screen comes up, select Ubuntu. So it's the default. If you just let it reboot, it will by default go into Linux, okay? So start doing that now, because we'll be playing with it soon. Okay, let me know if you have any problems, but I'll keep going with the lecture. So why is Linux important? Why is it popular? Why do we use it? Why doesn't everybody just use Windows? I think the main positive thing about Linux is it's open source. So you may have heard of the word open source before. It really just means free. So everybody can download it freely. And also, open source means that if you're interested, like Linus, who invented it, he made all of the source code that built the operating system also available. So you can go in and have a look at the code if you're so inclined. You can modify it. You can make a custom Linux kernel and build your own operating system using that code. Now, this is something you cannot do with Windows. Windows you pay for. I know it comes on most of your computers, but you actually pay for it when you buy your computer. And if you want to modify it, you can't, because the code which was used to build the operating system is not freely available. All Linux and Linux variants have source code available. So there are other examples of open projects. Hardware projects as an open source computer. But one simple example is OpenCola. So if you wanted to try and make Coca-Cola, you can't find the recipe anywhere because it's well, closed source, if you like. There's no recipe which you can download and try to make it for yourself. But people have tried to make something which tastes like Coca-Cola and made the recipe open to everybody, so it's called OpenCola. I haven't tried making it, but the operating system's the same sort of thing. You can try and build it yourself. You can build a Linux kernel by yourself and modify it. So it's pretty handy. Now, that's important, as we'll see later, for research projects where you may need to build custom kernels for custom hardware and so on. That's quite hard to do with Windows, but you can do it with Linux. So Linux became very popular. One of the main reasons was because it was based on another system called Unix. So I think Linux probably comes from Linus plus Unix, perhaps. I'm not sure, but maybe that's where it comes from. Now, this was a commercial operating system which was developed long before Windows was around. And these two, Kenneth Thompson and Dennis Ritchie, who worked for Bell Laboratories, has anybody done any C programming before? You've heard of the language C, C++? These guys pretty much invented it. The textbook on C is Koenig and Ritchie, so that's Dennis Ritchie. So these guys are real founders with computer science, full stop. Now Unix is still used a lot. Mac OS is based on Unix. It's a Unix system. Most web servers run Unix. Most IBM mainframes use Unix. But it's not the same as Linux. Linux is truly free and open source. Okay, but that's probably why Linux became popular, because it was based on a system which already existed, which people were already familiar to use. So Unix uses a bash script like we're going to learn how to use today. So Linux, how are we going with the booting into Linux? We all managed to get into Linux yet?
That's the password?
No. Sorry, yeah, you need a password, don't you? There are two users there. One has administration privileges and one doesn't. Okay, for the meantime, we'll log in as the DTH, sorry, what's that? I forget the name of it now. Data Tools Hands-On User, so the bottom one. So that one does not have administration privileges, but it means that you can't mess it up, I guess. So the password is RWDC. Okay. So what you've just logged into, hopefully you've logged into, is called Ubuntu. So it's this one here. Okay. There are lots and lots of different Linux distributions, and people get quite enthusiastic about a particular distribution. For example, well, this one's Linux Mint became the most popular one recently, I think, because it's very easy to use. Ubuntu is still the most widely used because it's used on a lot of servers and a lot of IoT, so Internet of Things projects. Ubuntu is very widely used. I actually come from Fedora background. That was my operating system of choice. And if you get really, really geeky and you want to build everything yourself and know how everything works, so install all your drivers by yourself, then you go for Arch Linux. So this is really bare bones, and you install everything yourself. Ubuntu works on most computers out of the box because it's probably the most popular, most widely distributed operating system. Now, they all are based on the same Linux kernel. So the Linux kernel is like the core of Linux. But on top of that, you've got different package management systems, so ways to install software. You have different user interfaces. So the one that you've got now is called Unity. That's different from the Unity that we have a lecture on tomorrow. which is completely different software, totally unrelated, but the user interface for Ubuntu by default is called Unity. I think it's based on GNOME, which is what most of the others use. Unlike Windows, you've got one kind of Windows. You get Windows 10, and that's pretty much it. With Linux, even if you've got Ubuntu, you can take away the user interface, the GUI that you have now, and you can put on whatever you want. You can put on KDE or GNOME 3, or there's so many different kinds available. So Linux is fun like that. You can play around with it. Okay. So, like I mentioned before, Ubuntu is often used for as a web server operating system. I think that's because it's quite a stable operating system. And Ubuntu is actually managed by a company called Canonical, which is a commercial company, even though the software they make is all free, is all open source. It's also quite often used in developing countries because it's free. So there's a lot of schools, developing countries, which they learn Ubuntu by default, not Windows. Now, Ubuntu's been around for quite a long time, so we're up to version 16.04. So with each release, there's usually two. So the next one is 16.10, and the one after that is 17.04. And within the releases, there's developmental releases, and then the long-term support releases are the ones which Canonical supports for 5 years. So that means you get software updates and security updates for 5 years after you install your operating system. So now, for research purposes, most people are still running 16.04. However, next month, 17.04 LTS will come out. Now, Ubuntu names each release after an animal and an adjective, I guess. So I don't even know how to pronounce this. I don't even know what kind of animal this is. Zenial Xerus, I guess. But the next one's Artful Aardvark. Yeah, they have quite cool names. So if you want to install, for example, 16.10 or one of the other releases, they tend to be more buggy. The LTS ones are usually the really stable ones. So the research community, for instance, will still be supporting 16.04. So Ubuntu is used in lots of places, aside from just computers like the one you have in front of you. There's a lot of Internet of Things projects which use Ubuntu. Things like drones, robots, smart network switches, all sorts of stuff is currently, even commercial things that you use every day are running off Ubuntu. Tesla uses Ubuntu. Google very heavily uses Ubuntu. And I'm not sure how these two use it, but there are many companies which base their systems off Ubuntu, either Ubuntu servers or Ubuntu software running on their devices. Okay, so let's have another look at the overview, and we're going to go into look at some of the basic tools. Now, you've got a GUI in front of you. We're not going to learn how to use the GUI. GUI is graphical user interface. Okay, so like Windows, you're used to using the GUI. So you're used to seeing a folder and clicking on it, dragging things, and so on. Okay, you can do that with Ubuntu too, and we're not going to learn how to do that because you can play with that and figure it out yourself. I'll just give you a couple of little hints, I guess. For example, this on the left here is kind of like your taskbar in Windows. You can use the Windows key to bring up a menu where you can start typing what application you want. So for example, if I want to open up Firefox, I'll start typing Firefox and it will come up, and then you can just select that icon and it will load. Is that not showing over there at all, is it? Yeah, sorry, so if you press the Windows key or click on that Ubuntu icon, it will bring up the sort of the command manager. And then let's say I want to look at some settings. I start typing in settings and it comes up with things which I can then go into and change all the various desktop settings and so on. The file manager, which is called Nautilus, is this one here. And that works pretty much the same way as Windows. Windows is a system where you can see folders. You can look inside these folders and see what's stored in them just by double-clicking and so on. I think these will all be empty, but okay. So you can have a look around. It's fairly intuitive. I don't think you'll have too many difficulties using the graphical user interface. Where it gets tricky is when we want to start using the command line. So that's what we'll look at next. So the operating system, while it has a graphical user interface, you can really run commands on the machine all through what we call a terminal. So this is text-based. You type in a command which tells the computer to do something, it will do it, and it will give you a report back. Okay? This is how computers used to work. Before Windows came along with the first version of a graphical user interface, all computers were just typing into a text terminal. Okay? So this goes around the outside of the operating system, so it's an interface to the operating system, and it means you can get right in and directly work on the computer. Okay? So there's lots of different shells available. The shell is the interface, the text interface to the Linux machine, and there's lots of different kinds of shells available. So originally, this is what a terminal was. When you said terminal, it looked like this. This is probably the one that most text terminals now emulate. The same system as the VT100, which is back in 1978. That was state of the art. You're not going to get pretty 3D pictures out of this screen. It's just text. Okay? Just text and a keyboard. That's it. You don't need a mouse anymore because you're just typing in commands and getting stuff back. Okay. Now, in Linux, we have a software terminal on top of the graphical user interface, usually. Sometimes when you try to be clever and install new graphics drivers or something, you lose your graphical user interface and all you get is a text terminal. So it's good to know how to use it in those situations as well. And this is the default Ubuntu one, which is the GNOME terminal. So if you want to get into the GNOME terminal now, you can do it at any time with Control, Alt, and then T. So T for terminal. Okay, so you can try that now, or you can do it from clicking on here, starting to type in terminal, and then you'll see it pop up. Right, have we all got a terminal window open? No problems? So has anyone used a terminal before? You can use them in Windows as well. In fact, Windows recently has, you can use Ubuntu's terminal within Windows, within quite a recent update, I think. Okay. So what are we looking at here? Up in your new terminal, you'll see a bunch of text up in the corner here, and a flashing cursor. Now this is where when you type, your input will read back to you. The prompt should give you your username here, and then the machine name, and then the folder that you're currently in. Okay, so yours will look a little bit different. Yours looks something like DTH something something user at, and I don't know what machine names are here. DTH at DTH-PC or something like that. Okay. Now see the little tilde there? That means that you're in your current home directory. This is the same concept as the home directory in Windows. You know, you've got home directory, which includes documents, music, pictures, and that's for each user has one of those. It's the same with Linux. Each user has their own home directory. Okay. So let's try chuck in a command. So just a really simple one. If you type in cal for calendar and hit enter, it will come up with a little calendar showing what the current day is. Okay? So that's kind of what you're dealing with. You type a function in, and it runs it and gives you a report back. And now that's exited and it's waiting for the next one. So as you've probably realized, you need to know all the commands to run. Okay, there's hundreds and hundreds of them. It's pretty hard to know what they all are, but you can sometimes have a guess. For example, if you think, oh, I really need a calendar, you can start typing in calendar, put CA, then autocomplete with tab. Press the tab key twice, and it comes up with a whole bunch of functions which start with CA. Okay. Yours will probably be a little bit different from these. This was run on a different system. Okay, and there's a few other things you can do, like for example, we're going to look at these commands later, but the cat command just shows you the end of a file. So there's a file here called services, which lists all the services that you have. So if you type in cat and then /etc/ and start typing the name of services, then use tab to autocomplete, it will come up and it will give you a big long list of services which are running. So the tab autocomplete is really, really handy, and it works both for functions which the system knows about and also locations like this one, services. Okay. So you end up hitting the tab key a lot when you're using the terminal. So next we're going to look at some frequently used commands for within the shell. Okay, first of all, I think the most important one is manual. So this command you can use with any other command, and it will give you basically a help file to tell you how to use that particular function. So when you're stuck, you don't know what a command is, type man and then the command name, and it will give you a help. So a little bit like, for example, there is a function called sleep, which really does nothing. It just stops the operating system and waits. So if you want to know how to use it, man sleep, and it will give you this kind of description on how to use it. So try that now. Try type in man sleep or anything. What was the one we used before? Man cat, for instance, and it will tell you how to use the cat function. Cat comes from concatenate, actually. It's not from cats, but. Okay, it's going to get a little bit trickier from now on. Okay, another really important thing about functions using the terminal is they usually have options. So you have a little flag. This minus sign is as a flag. You put a letter for a particular option, and then the argument for the function. So for example, if you put man k, this is an option for the function manual, and it will give you a different output from before. So actually you can type in man, and it will tell you all these flags. Okay? So that's man is the option for manual, and it's fairly massive, but if you type that in now, you'll see there's a description of all the flags which you can feed to the manual function. Actually, the manual documentation is Japanese documentation as well. Okay, so in this case, the K option gives you a little bit more information about the different sleep functions. So it gives a section number and a description for each. So the section number describes what kind of operation that particular one is. So here we have a list of types of sections. So if it's listed as 1, then it's a user command. It could be a bunch of any of these other things. You don't have to really worry about this too much. You're probably not going to use it, but if there's a particular function and you want to know what different modes it operates in, you want to know if it's a game that you can play, then you can use that K flag. But that's really just an example of how to use flags for functions, options for functions that you run. Okay, so as you could see, there were different. You can also use man to search by section number. So previously we saw that there is a sleep function here, which has section number 3. Section number 3 means it's a library function. If you want to know more about that particular library function, you can go man, the section number, and then the function, and it gives you more detail about what it does. Okay? Typically, just man and the function is enough if you're just stuck and want to know how to use it. So this isn't super important, but for some functions where there's lots of names which are used for several things, like sleep, for instance, it can be useful. Okay, now we've learned about how to use the manual. You're probably going to use that quite a lot today, I think. We're going to look at how we can change directories. So a directory is like a folder in Windows. So you start, when you open up your terminal, it usually starts in your home directory, and then you can move around into different directories using the terminal, okay? So the goal is to find files, right? Directories are ways to organize files. Now, in Linux, everything is a file, so they're abstracted. You don't need to know what they do necessarily, but you need to know the smallest unit of storage, which is a file, okay? And directories are really just used to organize those files into ways that make them easy to understand. So it is really just the same as Windows folders. And again, you can see them in the GUI as well. You can see these are files, these are zip files, and that's within this folder. You go into these folders, you'll find other files. So the end of the tree structure is a file. Okay, and the files are what's actually stored in your hard drive. Directories are just ways of organizing how to get to them. So the Linux directories have a tree structure starting with the root node. Now, you don't usually go back to the root node. It can be kind of dangerous if you do. If, for example, you run a delete or remove command at the root node, you're very likely to delete your whole operating system. So you don't usually operate in this field. You operate in these ones when you really know what you're doing, when you're trying to find library functions where they've been installed and that kind of thing. Except for the home directory. This is where most of what we're going to do today is all going to be done in the home directory. Okay, so your own personal space. You can mess that up as much as you like, and it doesn't matter. It's not going to affect the system. These ones will. This one will too. Okay, so just be a little careful. Actually, in actual fact, the user that you've logged into doesn't have privileges to edit any of these directories, just this one. So you'll be all right. Later on, we're going to log into the other one so that you can see how to use root privileges, root being the most powerful user. We'll see that in a moment anyway. Okay, so here are some commands which we use to navigate directories. First of all, this one here shows you where you are currently relative to the root node. So the root node is like the start of everything on a Linux system. Home is your own, is where all the user directories are, so your home directories, and this is your user. I don't think you have this name, you've got something else, but it'll be something like that. So if you type that in now, you should get it just come out with where you are, something like /home/DTH. Okay, so that gives you current location. It seems trivial now, but when you're dealing with, when you're 6 or 7 folders deep into a project, then that can be quite useful to know exactly where you are. Now, if you type in ls, it will give you a list of the folders within that directory. Again, you use ls all the time when you're dealing with the terminal. And again, you've got some other options. What you can try now is ls and then the hyphen a, which is, remember we looked at the flags before, man hyphen k or minus k. If we put in ls minus a, you'll see you get a different output. If you try that now, you'll see you get a whole bunch of little files with a dot next to them. The A flag means show everything. So the ones with dots are hidden files, ones which aren't really important for you to, they're not like you want to know where your pictures folder is, you want to see your music, you want to see those files, but you don't need to see profile caches and this sort of thing. So that's why they're hidden files. And the A flag commands the terminal to show everything, including those files. Okay. Here's another one. If we go ls minus f, it gives the slash to show that the directories. Pretty trivial. Or another variation of the A one, ls hyphen la, gives heaps of information. Try type that now and you'll see it will tell you a whole bunch of information about each of the files, including the hidden files. Let's see, can anybody guess what the left-hand column of that chart is? I think the far right is the file name or the folder name. That's pretty self-explanatory. One column to the left of that is when it was modified. The one before that you don't really have to worry about. But the far left-hand column has a bunch of DRWXs and hyphens. Does anyone hazard a guess what that is? So this stuff here. It does exist in Windows, but you don't normally see it. Any idea? This tells you what permissions are associated with this file. So whether you can read them or write them, or so whether you can edit the file, whether it's locked to this particular user, or and so on and so forth. So this can be useful when you're trying to run a file and it won't run, ls-l, and it will tell you what permissions are on that file. Okay. So Windows has permissions too. You'll come across Windows permissions issues too, but this is one way to check them in Linux. All right. Any questions so far? Okay, now we're going to be able to start shifting around. Excuse me. So if you want to make a new directory, there's this command, make dir. So let's make a new directory called work. Then when we hit ls, when we type in ls enter, we'll see that new directory called work. Then to change into that directory, we use this cd, which is change directory, cd work. Again, you can use your tab, so you just type in the W-O or the W and hit tab and it will autocomplete, and then you'll be inside that directory. So the terminal is now operating in that directory. And if you use that pwd command, you'll see that you're now in the work. Okay, that should all be pretty straightforward. Now we went cd to get into the directory. To get out of the directory, to go up one level in the directory structure, we go .. So cd, actually you don't need the slash, cd ... will go up one directory. Okay, so let's try that. make a directory, go into the directory with cd, and then go back up into your home directory again using cd dot dot. Everybody managed to do that? I guess at this point you might be thinking, why? Why don't we just use the GUI and double click on the folder and go into it that way? Double click on the executable to run a program like we do in Windows. Well, it's all very well when you do have a GUI and you can navigate like that, but there's lots of situations where we don't have a GUI. A web server is usually what they call headless. It doesn't have 3D or 2D visual. All you have is this. Okay. For example, in my lab, all of the servers which are running lots and lots of GPUs to do deep learning, none of them have a user interface, a graphical user interface. It's all text commands, and that's it. And usually that's the case. You don't, for those machines which are processing lots of data, they don't need a user interface typically. Their job is to crunch numbers, not to look pretty, so it's easy for you to get around. So you do use this, trust me. Okay, if everybody's managed to do that okay, let's get rid of that directory we just made using the remove directory. So now you should be in the home directory, one above work, and with rmdir you should be able to destroy that directory that you just made. So if you type in ls again, you'll see it's no longer there. Okay? Okay, I'm just going to give you a couple of minutes to use cd and cd dot dot and ls to just explore the directories that you have in your home folder. You can go further back if you want. You can go back to slash and slash etc and slash bin and slash user and all those folders and just have a look around if you like. But just practice using the cd dot dot or making directories and so on. Using the tab to list all the directories which you have available, so on and so forth. Let's try that for a little bit. Okay, now you're having a look around. This is what those various folders are for. Again, don't really worry about this too much. It's all a little bit technical, but if you're interested, this is what they all do. So again, with your current user, this is the only one you can actually make directories in. You can view all of these. You can go cd/temp and have a look at the temporary files which have been generated. There's probably nothing really of interest to you in here, I think. This one you use a lot if you put in a hard drive. If you plug an external hard drive or a thumb drive or something into your computer, then it will pop up in these two actually. It'll mount to /mnt as a folder, and then it will be available through this media location. So device files, for example, if you plug in a USB camera or something, it will show up in here as a device. Okay, we should probably keep going. Next of all, we're going to look at file operations. So we've been looking at folders and how to move in and out of folders, make new folders. Now we're going to look at files. So first of all, let's go back to the cat command. So this just shows the end of the file. So there's a file in this location called hosts, and this lists the hosts used by this computer. Okay? I don't know. I'm not sure if you've ever seen hosts before. Again, you use them in Windows too, but this is the local computer, and there's various other bits and pieces in the file. It doesn't really matter what's in the file. This is a text file which the cat command can then view. Okay. Again, with an option, you can see the line numbers. It's just a text file with lines of text in it. You typically just use the cat command when you want to see what's in a file. If it's a text file, you can just go cat and then the name of the file, and it will just show you very quick way to see what that file contains, to see if it's the file that you want to use. Okay. Now you can use the copy command, cp, to copy a file. Actually, this might be incorrect. Excuse me. So this is like right-clicking and going right-click copy. Okay. /etc. Okay. Okay, so what this does, remember that host file that we just had a look at with cat? It copies that host's file, this file here, to a new file called foo.txt in our current directory. So wherever you are now, hopefully in the home directory somewhere, you will now have, if you go ls, you will see there is a foo.txt, a new file called foo.txt. So if we again run cat on that, cat foo.txt, you'll see the same content as we saw in the previous hosts. Okay. Now, remember I said that anything in here you don't have permissions to edit? Now that you've copied it into your home directory, you can edit it as much as you like because you have the permissions to operate on files within your home directory. Okay, so what if you want to copy whole folders, including the files within them? Then you use the same copy command, but you use this R, recursive, which means it copies all the directories below that as well. Okay. So again, in this etc folder somewhere, there is a folder called Java, because Linux comes with Java libraries. You can copy that into your home directory in a new folder called work. And then you'll get all those files in your home directory. Okay, it looks like that on these computers, maybe we don't have that Java folder. Did anyone get an error, or did you manage to do it? Okay, if you are clever and use the tab, you'll see that in this computer it's called Java 8 OpenJDK. It's a different folder name. Did you manage? It doesn't matter. This is just an example. You don't have to. You could copy anything you like. This was just an example. So it would be look something like this. Use a tab to autocomplete. Sorry, I missed out the recursive thing there. So use recursive for directories. Cool. Now if we go ls, we will see we have work. We go into there, and ls, we can see all the Java files. Okay? Right, is anyone struggling with this, or it's all okay? Please ask questions if you're stuck. Okay, that's how we copied stuff. Now what about if we want to move stuff? Then we use the move command, mv. You're not going to be able to run anything on /etc with move because it takes it from where it was and puts it elsewhere. So it's like cut in Windows. So previously we had copy, and then it would paste it wherever your terminal is. With move, it removes it from the original location. So you can only do that with files in your home directory currently. So that file that you made foo.txt, let's move that into the work folder where we put all the Java stuff, just using move foo.txt and then into work. Then if you look at work, you'll see that foo.txt and all the other Java stuff that we copied over is also in there now. Now, in Bash, there is no there is no rename command as such. All you do is move the file into another file of a different name. So you can use move for renaming as well, which when you think about it is intuitive. You're moving that file to a different file with the same name, with a different name. So it gets rid of the original one and makes a new one with a different name. Okay? So renaming and moving are pretty much the same thing. Remember we used that command rmdir for removing directory. So how about removing files? You can remove files just with the rm command. Now, in actual fact, you can remove directories with this command too, using again, the recursive option. Recursive, you use the same command, but the operation is for directories rather than files. Okay. So this is actually two flags, the I flag and the R flag. It's the same as typing rm -I -R would do the same thing. You can put them together. Here the I means please check every file. So when you're deleting a directory with the R command, there may be 20 files or 20 folders underneath that directory, right? In that case, with the interactive one, it checks every one. It stops you and says, are you sure you want to delete this? And then you go through typing yes, yes, yes. If you don't use that, if you just go rm -R and miss out the interactive, it will just delete everything indiscriminately. It won't check each one. Okay? So you can type in man rm to see what all these different options are. There's lots of them. Again, that man is really helpful, man rm, and you'll see what you can do. If you never use man, you'll probably never learn the little tricks which help you to become really fast at using the terminal. So every time you use a command, you think, is there an easy way to do this? Man, and then the command, and then you'll see all the flags that you can use, and you'll get used to all the different all the little tricks which make things quicker. All right, so far so good. If you're good at using the terminal now, we can have a look at system management. Now, this part of the lecture, you can't do anything with your current user because you can't change anything on the system with your user. It's like in Windows when you have an administrator account and a non-administrator account. You're currently in a non-administrator account. But in Windows, if you have an administrator account, you can do pretty much anything, right? As long as you click that yes when the window comes up, you can delete really bad stuff which you shouldn't. You can install software system-wide which maybe shouldn't be installed system-wide. You can do naughty things, right? It's the same in Linux, but it's harder to do naughty stuff because every time you have to become the root user, the super user. In Windows, if you're an administrator, you always have that privilege. In Linux, even if you know the root password, you don't really run in root the whole time. No one ever uses that user, except when they want to change something on the system. It's the same in Mac OS is the same. And that is one of the main reasons why Linux and Mac OS are much, much stronger against viruses, because whatever nasty thing, malicious code wants to operate, it can only do it if it has the ability to run as root. And if it doesn't know the root password, it just can't do it. Whereas in Windows, as soon as you, as the administrator, chose to install something that, like a ActiveX control on your browser or something, then all of a sudden it has control. It can do what it likes. So that's one reason why Linux is and Unix is quite good against viruses. Okay, so you don't give away your root password, obviously. You may have heard about the little scandal that Apple had, was it earlier this year, where you could log in as root without the root password if you did a rather bizarre combination of things. So there's always software fixes to stop that sort of thing from happening. But generally speaking, there's nothing you can do without the root password. So when you're a normal user, like the users you're using now, and you want to use root, either you need to change into root using the su command, which is switch user. That's not going to work because you use sudo to run something, which runs something as root. We use this all the time. We very, very rarely change to the root user because once you change to the root user, you've got to be very careful. So normally we'll just run single commands as root using this sudo command, and then it will ask you for your root password or the user password if you have the permissions. If you try that now, if you try run anything, let's try sudo, well, you can just use this one. Don't worry about what the command does at the moment. It will say your user is not in the list of sudoers, okay? Which means that your current user, doesn't matter what you do, you're not going to be able to run as root. You're not allowed to. But if you log out and log back in again as the other user on the computers, then that user is in the list of what we call sudoers, so people who have access to sudo, and then you can run this command. I don't think we really need to do that today because you'll figure that out pretty quickly once you start using Linux, how to use sudo. It'll say you don't have privileges. You can't do this because you don't have privileges, and then you go, oh, okay, sudo, and you run the same command, and usually it works. You type in your password and you're away. Okay? Now, in Ubuntu, you never, ever, ever log in as the root user to the GUI because it's very, very dangerous. If you do that, who knows what could happen. You just never do it. So if you need to do something on the computer which needs root, either you do it in the terminal with sudo, or programs which need it, like package management programs or software install programs, will ask you for the password. But generally speaking, never go to the login screen where you were previously and put the username root and log in with the root password. It's just something you don't do. So it's a little bit different from Windows from that point of view. Okay. Yeah, we're getting through pretty well. So last of all, we're going to look at shell scripts. Okay. So this is, you've learned a few functions, right? cd, rm, cat, echo, those kind of commands. Now we're going to look at how to combine them into one, run them with one script. Okay. So it means that instead of having to type lots of commands to do something, you just put them all into one file, which is a script file. It's like in programming you have a file with a list of commands for whatever you want to do, right? It's the same with Bash. You can do the same thing. Okay? So these can get really complicated and really long. They have variables. They have all sorts of funky stuff going on. Then you can then run the whole list of commands with just the name of the script, and that's it. Okay? So here is a simple example. There's a bunch of new commands here which you're going to need to look up man for, but let's just have a go at making a script. Okay? This touch means make a new file called this, an empty file. Okay? And then echo basically just echoes whatever you type. And here we're echoing this text, this string of text in inverted commas, to the sleep file. So this pipes it into the sleep file. Now this is a bit of a jump from what we've been working on previously. It's getting a little bit more complicated, but there's heaps of little things like this in Bash. Well, of course, we can't learn them all today, but if you wanted to write Bash scripts to do little tasks, Stack Exchange or just searching on the web, you'll find lots and lots of little tricks for how to do things. But if you run this command, it will echo this text into the sleep file. And then if we use cat to have a look at what's in the sleep file, you'll see these commands. So then if you run that file that you just created using this sh command, it will go through and run these 3 commands as if you typed them in. So it does it in one go. So try that and see what you get. So if everything goes according to plan, it should run that script, it'll print out start, and then it will just sit there and do nothing for 10 seconds, because remember, sleep is that rather useless function which just waits, and then it will print out end when it's finished, and you'll go back to the prompt. So instead of sleeping in that time, I mean, you could have done some calculations, you could have, bash scripts can take arguments as well, so you can run a bash script that has inputs and it can do something on those inputs and then output whatever you calculated from the inputs and so on. They're very handy when you don't want to write a program which you need to compile or something, you just want to do something simple on the system, you can write a bash script. A great example is, let's say you have a big folder full of images. This might be something you've come across, and they're all in capitals. Right? The file names are all in capitals. The extensions are also in capitals. You want to rename it so that the extensions have small letters, not .jpeg in capitals, but .jpg in small letters, because some application that you want to run doesn't accept uppercase letters. You can use a bash script to just run through and rename all those files automatically for you. That's the sort of stuff that bash is really handy for. Or renaming files. Let's say you have a bunch of photos which are called like DSC 9065 or whatever you get from your camera, and you want to rename them to 1, 2, 3, 4, 5, 6, 7. You can write a bash script very easily that will run through your folder and rename those files so you don't have to do it manually. So it's very handy for that sort of stuff. This is a trivial example, but you could very easily learn how to do that if you do a little bit of searching around on what commands to use. Image resizing, that kind of stuff, is also very handy with bash. You've got a folder full of images that you want to resize. A couple of commands, it's done in bash. Okay, did anyone get that running? No? It's not working? Okay, I think you're pretty good with those. Now that was, as you can probably see, it's very tedious using the echo command to write stuff. You don't normally do that unless it's a very short example like what you've got there. Normally you will use an editor to write scripts. Okay? Now, for editors, you've got, this is like Notepad in Windows, right? Or Notepad++ for those of you who've done some programming. It's software for you so you can write text files or .c++ files or whatever. Ubuntu has a bunch of them pre-installed. This one is a GUI one, so it looks like Notepad. It's a little bit better than Notepad because it does some highlighting and that kind of thing, but it works in the GUI. So you can double click on a text file and it will open it in gedit and you can edit the file. That's all very well and good. Actually, go and have a look at that foo.txt file. If you go into there and double click on it, it will open up with gedit by default. Or that .sh file that you just made as well. You can use the file browser to find that file, double click on it, and it will come up using this gedit editor. So you can try that now. And you can edit it and save it just like you'll be familiar with the workflow for that editor. These two, however, are used in the terminal only. They don't have a GUI interface, so we'll look at them in a minute. First of all, if you can, although you can launch the gedit editor from the GUI, when you're working away in a terminal, it's usually easier just to use the gedit command and it will open it. So for example, that sleep10 file that you just made, some of you had it put in twice. If you just take out those last 3 lines using this, go gedit sleep10.sh and use this ampersand to make it open in the foreground. So it doesn't, that means you can still use the terminal. It opens a new process. If you miss this out, it locks up the terminal, so you can't use the terminal anymore until you close the file. So you can try both if you want to experiment, but generally you'll use this ampersand. Okay, give that a go. Now gedit is pretty easy to use, so I recommend that you use that for this kind of thing when you can, and maybe look into terminal editors when you have no other choice. We'll look at that in a moment. All right. Now here's a tricky one. This one is really going to confuse you. One of the terminal editors, this means you can edit within the terminal. It doesn't open another GUI thing. This means like on a web server or something like that, you can use this editor and you don't need a graphical user interface at all. The one that most, I would say, geeky people use is this one. It's very hard to use. Very hard to use. It's very, very confusing. This command here will just make a new file called hello.txt, and then you can try your best to edit this file within the terminal. Just try that now. But as you'll realize, it's not intuitive at all. You need to pretty much learn all the commands all over again. I don't really use Vim. Some people just swear by it, and it's very, very fast. If you know how to use it, it's very quick to use. But for people just starting out, it's confusing. So I'll show you in the next slide how you would put in a simple hello bit of text. First of all, you need to press I for insert mode, and then you type in whatever you want. Backspace will modify it. And then you need to hit escape to get back into the command mode. And then this colon is like an action modifier. And then you have different, like WQ will save and quit. I don't know why it's W. And Q exclamation mark will quit without saving. It's got all these commands. Basically, you have to look up the Vim manual and learn the commands. Simple stuff like navigating around the file with the arrow keys is not really simple either. Usually people use the navigate mode. So again, it's another command, and then you use W, A, or I can't remember what they are now, like D and F and H and J to navigate around. It's difficult, okay? But if you put in the time and learn how to use it, you can be very, very fast. It's pretty incredible. There's actually a tutorial, a game, which teaches you how to use it. So it's basically a game which for which you can learn all the commands. I'll just look it up. Anyway, while you're probably confused by that, don't worry about it, because there's a much simpler one called Nano. It's a bit slower to use, but Nano is really lightweight, and the great thing about it is it has a help at the bottom, so it tells you exactly what to do at each step. So if you're stuck with your graphical user interface having died on you, you can open up configuration files with Nano and edit them pretty easily. I don't think this really needs a tutorial, because the tutorial is pretty much built into it. It's pretty good to use. Okay, now we're running out of time a little bit. So, did you have a go at using Nano? Did you manage to edit a file? Cool. Now this is something which I don't know if we won't really have time to do it today, but it's something you can try. Use your editor of choice. You're probably going to want to use gedit. It's the easiest to use, but if you want to use Nano, that's cool. If you're really keen, you can use Vim. you can try and make a bash script like the one that you had before, the .sh file with the sleep, but instead make it print hello, then count from 0 to 9 at 1 second intervals. So you can use the sleep command for that, and then prints bye. So printing stuff is just echo. You know how to do that. So in your script file, it will just be echo hello. Then the next line is where it gets interesting. The hint is, which will give it away, man for. You've used for loops, right? You used for loops probably yesterday, I think. Yeah, for MATLAB, I think you would have probably done for loops. Bash has for loops too. So a for loop can go from 0 to 9, and then print that number with echo, then sleep for 1 second. So that's a little exercise for you. Okay, so I've just made that file. Let's see how you're going. It looks something like this. I'll look something close to that. So the for syntax is a little bit different from what you're used to in MATLAB, but it's the same concept. So you have a new variable, this lists through all the things you want to iterate through, and then the echo can print variables, sleep does the sleep that you've done, and echo prints out text to the screen. Okay? So if we run that, okay, we're in. Let's just check that foo is there. Yeah, it is. Foo.sh is there, so we run it with sh. Let's check it works. Sorry. It says hello. Yep, starts printing out numbers once a second. And hopefully it should say bye. Yep, and then it stops. Okay, so that's a really simple bash script. Doesn't really do anything useful, but I think you get the idea. Okay, now we've got 5 minutes left. It's not really enough to move on to the next part, which is remote login. This is something that you're probably going to want to do at some point. Basically, let's say you want to manage your web server, which doesn't have a GUI interface, but you want to do it with a terminal. Then you log into that web server using what's called SSH. Secure shell tool, SSH. Okay, or like for example, in my lab, when I want to use the really powerful server with like 6 GPUs in it, then I'll log in with SSH and do all the programming and stuff that I need to do there. Well, I write my program on my local computer, but then I'll run the program over SSH using this command. Okay, so this is what it looks like. In your terminal, you will go SSH into a user at a remote machine. So this is usually done with an IP address, or if you have your DNS set up, it could be a domain name as well. Okay. Now I just set up a little web server just for today. We don't really have time, but you can try it. If you go SSH test user at and that IP address there, you will be logging into a web server in Singapore. Okay, which is running Ubuntu. The password is DTH2018. Okay, so that's miles away. That's a web server which is serving websites. And the server is a virtual machine over somewhere in a big server center in Singapore. Okay. So yeah, for the XXX part, you put in that IP address 167.99.65.36, and you'll get into that machine. Now I think I just checked it before, and I think there is an issue with the bash profile. So in actual fact, this is a little risky, but you can also log in like this, and then you'll get a full bash. Now this is what I was telling you not to do before, and you're logging in as the root user. So if you do that, please don't delete anything in /etc or any of those important directories, okay? Because it will kill my web server. It's not an important web server. You can kill it. It's not going to be really major, but if you use this test user instead, that will also work. But I think there is an issue with the bash profile, so it doesn't come up with a prompt, and tab doesn't work. So that one's probably easier. So if we had time, what I wanted you to do was use Nano as a terminal editor to write a little script file and then run that script file on the web server. It would do exactly the same as what happens on your computer, but you'd be doing it on a server in Singapore somewhere. Okay, so that is usually how you use SSH. Okay, and that is just time, isn't it? So I mean, if you want to play around with that and try and use Nano to write that file, you're welcome to. I will leave that web server running for the rest of today and kill it sometime tonight. Okay, so thank you for your attention. Your next lecture is on Python, and you'll be using Linux. So you'll again be booting into Linux and using this operating system. But you can probably use the GUI a lot of the time for that. The editor, you can use gedit. It's no problem. Okay? Okay, any questions? Is Linux a bit scary? I mean, I've used Linux for years and years and years. I don't use Windows at all, except for PowerPoint presentations. I only use Linux. A lot of research projects, for example, a lot of, you see people working in artificial intelligence, and they will release their code so that you can try using their algorithms. 9 times out of 10, they've tested and run it on a Linux system. So, except for the really well-known ones, like Caffe works, the Caffe library for deep learning works in Windows and it works in Linux as well. But most researchers in artificial intelligence and in computer software engineering, full stop really, definitely sort of at academic research level or research institutes, most are using Linux for development rather than Windows. A lot of that's because everything's free and open. So it's definitely good to know how to use if you want to do research in artificial intelligence or computer science. Okay, I know it seems a little bit scary that you're not used to writing commands into a terminal, but actually Google will help you with anything you need to do. You can Google, there's a great site called Stack Exchange, which you may have used, I'm not sure, but Stack Exchange has the answers to everything. So if you get stuck on a bash scripting problem, or you need to configure something and you're not sure how to do it, Stack Exchange will usually give you the answer just like that. And even if you don't get the answer, you can ask a question on Stack Exchange. Did anyone manage to log into that server? No? Should just be SSH command. Oh, that's fine. If you already closed it down, that's no problem. But okay. All right, thank you. I will see you again later this afternoon for OpenCV lecture. Again, that will also be in Linux using Python. So it'll be a combination of the morning's lectures. Okay, thank you very much.